This is Allison from East Cobb Tutoring Center. Today we have two objectives. First, to find a unit vector in the same direction as vector b, and second, to find the angle created in the coordinate plane by vector b. So first, let's start with the unit vector. To find a unit vector, all I need to do is take my vector b and divide it by its magnitude. And that will give me my unit vector. So the magnitude of this guy is the product of the squares of the components. So let's see here, that will be the square root of 9 plus 9, 3 squared plus 3 squared. And then I am going to simplify this quite a bit so that it looks nice and tidy. So my unit vector is going to be negative 3i plus 3j over the square root of 18. The square root of 18 is 3 root 2. So my unit vector, the 3's are going to all cancel, and I'm going to have negative 1 over root 2 I plus 1 over root 2j. Now, this isn't simplified enough for my taste, so if this were in my class, I would expect my students to rationalize the denominator. So a final answer for my unit vector is going to be negative root 2 over 2 I. Oops. Oh, I'll do that. Root 2 over 2. Try one more time. Let's see. Negative root 2 over 2 I. I think the problem I'm having is that it is too close to the bottom of the screen. So let me try it over here. Negative root 2 over 2i. There we go. Plus, there's a plus up here too, didn't have. Root 2 over 2j. So this is the unit vector in the same direction as the vector that we started with. What makes this thing a unit vector is that if we were to compute the magnitude of this new vector, the magnitude would be 1 unit. Now let's go back up to the top, and let's think about constructing an angle in the coordinate plane that goes with this one. The first thing we need to note is where the vector is located on the coordinate plane. So on the coordinate plane, the I component is negative 3, so that means we go 3 in the negative direction on the x-axis. And because j is positive, we go up 3 in the y direction. So our vector starts at the origin, something like that. The angle that we're looking for is this guy, the angle made with the x-axis. So what I'm going to do is use arctangent. The tangent of our angle, the tangent of theta, is equal to y over x, so it's going to be 3 over negative 3. So now we have to do a little bit of thinking. If you were to use your calculator here, you would get that theta is equal to negative pi over 4 degrees. Here's the trouble. Negative pi over 4 degrees is in the fourth quadrant, and our vector is clearly not in the fourth quadrant. So remember that arctangent has a limited domain from negative pi over 2 to positive pi over 2. So we just need to find the other angle on the unit circle has a tangent of negative 1. We can achieve this either by using the unit circle or just by adding pi to this value, and that will put us in the second quadrant where we want to be. So my final answer is 3 pi over 4. So now we've found a unit vector in the direction of our vector, and we found the directional angle that it makes in the coordinate plane. I hope that was helpful.